Now there is one very important topic that is actually percentage of purity and percentage of yield. Okay. See, what is percentage of purity? See, the percentage of purity is, suppose you are taking 100 gram of anything. Let it be 100 gram of you know 100 gram of suppose you are you got A. So in that 95 percentage of 95 gram of pure A is there. Remaining 5 gram it is actually impure A. Impurity is there. Okay. So the percentage of purity is 95 divided by 100 into 100. So this is going to be 95 percentage. Okay. So this is the case, like this is nothing but a 95 percentage of pure compound. And now percentage of yield. Let it be, you are taking a reaction. So, A is converting into B. So when you are converting into A is converting into B, so actually if the reaction is happening, okay, properly, in our conditions, if the reaction is happening, suppose 100 gram of B has to form, but when you follow a particular reaction, 95 gram of B is formed. This is the real condition. This is the theoretical condition. Theoretically, 100 gram of B has to form, and now like 95 gram of B only has formed. So the percentage of yield is, so 95 divided by 100 into 100. So this is going to be again 95 percentage. So the percentage of purity is like how much pure product is present in it. Percentage of yield, like how much is the quantity of the product it has formed. Okay, and now so like these two quantities, so percentage of yield and percentage of purity, that is a very important type. For example, you consider a pharmaceutical industry. A pharmaceutical industry. So in that, the many drugs it is going to come, right? Many drugs it is going to come. So in that, like suppose if even a small amount of immunity is present also, that is going to lead to, complications, health problems, and maybe it can even become a poison. Okay. So this is the importance of percentage of purity. Of course, there are some applications, maybe this, talcum applications, cosmetic applications, a little bit of impurity is fine, no issue. But if it is about drugs, if it is about food, like a percentage of purity is very important. You should have at least a 95 percentage purity should be there. So that is what the importance of percentage of purity. Now let's see, like and percentage of yield. Now another important purpose. You consider one particular industry. Like now you see, there are many industries. For example, suppose N2 plus 3H2, it is giving 2NH3. Okay. So N2 plus 3H2 gives 2NH3. So this is actually, in normal case, it is giving 100 gram, but when it is, like or like a 95 percentage of the product. In some another condition, it is giving 70 percentage of the product. So what we need to understand is actually 95 gram of 95 percentage of the product. This is going to be very important because when it is 95 percentage of the product, like it is going to be the industry is more economical, it is more producing, right? Okay. So percentage of yield, it is a very important type. Now let's see how we can find the percentage of yield. For example, percentage of yield is actual yield divided by theoretical yield into 100 percentage. Okay. So, if I am taking a particular reaction, let it be, conversion of salicylic acid, C4, C7H6O3. This is converting into aspirin, C9H8O4. This is actually salicylic acid. This is actually aspirin. Okay. So this is what it is. And suppose the molecular weight of so according to this reaction, 1 mole of salicylic acid, it is going to give 1 mole of aspirin, right? Suppose if you are using 1 mole of salicylic acid, it is supposed to give 1 mole of aspirin, because the ratio is actually 1:1. Now you see, like suppose if you give 100 gram of salicylic acid. The question is 100 gram of salicylic acid. It will give actually 121 gram of aspirin. Okay, 121 gram of aspirin. And so let it be 1 mole of salicylic acid. Actually, this is going to be salicylic acid. Actually, it is going to be, yeah. So it is going to be 138 gram. 1 mole of aspirin. This is going to be aspirin actually. 180 gram per mole. Okay. So this is actually the yeah. So 180. So if 100 gram of salicylic acid, if it is giving 121 gram of aspirin, we will see. So number of moles in this case, it is supposed to be 100 divided by molecular mass. Actually, number of moles, it is as hope you remember, mass divided by molecular weight. So this is actually the number of moles, right? So 100 divided by 138. So I don't know how much you will get. So you will be getting around 0.725 mole. Okay. So if you are using, okay, so this means 0.725 mole aspirin, right? So it is supposed to give a, so 0.725 mole of salicylic acid. So it is supposed to give 0.725 moles of aspirin, right? So, the mass is going to, mass of aspirin is, going to be 0.725 into 190. So this is how much you may get around, you know, 130 gram, 130.5 gram. This is the theoretical yield. This is supposed to be the theoretical yield. But what we got is actually 121 gram, right? 121 gram of aspirin. So we will calculate actually percentage of your purity. Percentage of purity is actually 121. 121 divided by 130.5 into 100. So you will get around 92 percentage. 92 percentage. So the percentage of purity is 92 percentage. Sorry for making it in a small space. Actually, you will get the yield is around I will write again 121 divided by 130.5 into 100. So this is going to be 92.5, 92 percentage, 92 percentage. Okay. So 92.92 percentage. So this is the theoretical yield. Okay. So now now I hope you are very clear. So the percentage of yield is how much is the real product, how much product is formed divided by calculated amount, calculated yield into 100. So this is nothing but the percentage of purity. Okay. Yeah. Now let's see how to find the percentage of purity. See, for example, uh, you know, so percentage of purity of the product is percentage of purity of product is so a mass of the pure product. So you remember this word, mass of the pure product divided by total mass into 100. Okay. So this is what it is. And now, if I tell you an equation actually, see, you are, we can go from one particular equation, calcium carbonate plus 2HCl. So calcium chloride plus H2O plus carbon dioxide. Okay, suppose you have used 10 gram of calcium carbonate and think that it has formed 22, yeah, so 2280 centimeter cube of carbon dioxide gas. Okay, so that means 2.280 liter. Okay, so centimeter cube is nothing but it is actually ml. So if you want to convert that into liter, so you can go into divide by 1000. So this is how it is making. Uh, so now, so they are telling that is they have they produced a 2.280 liter of carbon dioxide. So what you can understand, so calcium carbonate is to carbon dioxide is it is actually 1:1 ratio according to the equation. So the question is uh, actually, see, chalk it is made with almost purely it is a calcium carbonate. So they are asking you if 10 gram of calcium carbonate, okay, 10 gram of chalk. So it has produced when it is reacted with HCl, it has produced 2280 centimeter cube of carbon dioxide. Then what is the purity of this chalk? What is the purity of calcium carbonate? This is the question. So what we can do? Yeah. So now they said that we can know calcium carbonate is to carbon dioxide. The ratio is to 1:1 ratio. Okay, 1:1 ratio. Then what the idea we can make? So number of moles, one mole of any gas, one mole is equal to 24 liter. Okay, so number of moles 2.280 liter divided by 24 liter. So 24 liter. So this is going to be roughly around. So I am not sure actually this value how much it is coming. It is I am not sure. So we can calculate it. So it is no need to calculate at this stage. And so this is the number of moles. So this is So one mole in 24 liter, like the number of moles in 2.280, it is 2.280 divided by 24. Okay. So like mass, like the total mass it is producing would be number of moles into molecular weight. Molecular weight of calcium carbonate is 100 gram per mole. 100 gram per mole. So mass it could be number of moles, so we can use this one 2.280 divided by 24 into molecular weight is 100. So this you will get approximately 9.5 gram. 9.5 gram you would be getting. Okay. So that means like the carbonate calcium, like carbon dioxide, it is going to be 9.5 gram, right? Yeah. So yeah, sorry. The mass of calcium carbonate, yeah. So yeah, sorry. This is going to be like a mass of carbon dioxide is going to be 9.5 gram. Okay. So this is going to be like the mass of calcium carbonate versus 2.280 divided by 24 into 100. So this is actually the mass of calcium carbonate. 100 is mass of calcium carbonate. 2.280 divided by 24 into 100. So this is you will get 9.5 gram. So that means like the percentage of purity is going to be 9.5 divided by 10 into 100. Okay, so this is going to be, so like 95%. Okay, 95%. Yeah, so this is what it is. So the percentage of purity of calcium carbonate is nothing but a 95%. Okay.